Welcome students to the second lecture on foundation course for students for class 11. In this lecture we are going to discuss logarithms. We know that the number system is very much essential to work mathematics. What a number system or a numerical system is? It is a system of naming or representing numbers. There are various types of number systems in mathematics like binary, decimal, etc. Let us see some of the number systems. Binary is a number system whose base is 2, which means that the two symbols 0 and 1 are enough to write a number in binary system. The second system is octal, whose base is 8. We need 8 symbols to write a number in octal system. So the 8 symbols are 0 to 7. So we use the decimal system for simplicity. The base of decimal system is 10 and the symbols that we use are 0 to 9. You will understand much better if I go with one more number system, that is hexadecimal, whose base is 16. So we use 0 to 9 as we use in decimal. Along with that, we use A, B, C, D, E, F, 6 alphabets of English. Now let us try to understand more about the system that we use, which is decimal system. So the numerical system employing 10 as the base and requiring 10 different numericals, the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 is called decimal system. So in decimal system, let us try to write few numbers. 12, 312, 7,54,523, 4,521, 99,99,999, 5,42,155.987. So these are few numbers that have been written in decimal system or in the base 10. Let us choose few numbers which can be easily written in terms of multiples of 10 to understand the decimal system. 1 can be written as 10 to the power 0. 10 is equal to 10 to the power 1. 100, which is 10 into 10, can be written as 10 square or 10 to the power 2. 1000 is 10 to the power 3. 10,000 is 10 to the power 4 and 1 lakh is 10 to the power 5. So these are the numbers which can be easily written in multiples of tens. Now when 10 is equal to 10 to the power of 1 and 100 is 10 to the power of 2, let us choose a number, say 68, and if we would like to write 68 in terms of power of 10, I'll write it as 10 to the power of n. Now what should be the value of n? Since 10 is 10 to the power of 1 and 100 is 10 to the power of 2, 68 lies between 10 and 100. So therefore, the value of n should lie between 1 and 2. Similarly, 100 can be written as 10 to the power of 2 and 1000 can be written as 10 to the power of 3. So therefore, let us choose a number between 100 and 1000, say 777. And if I would like to write the 777 into power of 10, so let it be 10 to the power of n. So now in this case, since 777 is between 100 and 1000, 100 is 10 to the power of 2 and 1000 is 10 to the power of 3, the value of n should be between 2 and 3. So therefore, any number can be written in terms of power of 10. It is called exponentiation to 10. Now for any number x such that x is greater than 0, x in exponent form is x is equal to 10 to the power of n. So x can be any number. Say 50 can be written as 10 to the power 1.7. 316 can be written as 10 to the power of 2.5. 8912 can be written as 10 to the power of 3.95. 55,347 can be written as 10 to the power of 4.74. Thus, any number in decimal system can be written in terms of nth power of 10, where n can also be a decimal number. Now, what logarithm is? Logarithm is inverse function to exponentiation. Now, till now, we have tried to write any number x in terms of 10 to the power of n. If I apply log to x to the base 10, log of x to the base 10 is equal to n. To understand this, let us try to write the exponent form and the corresponding logarithm form. 1 is equal to 10 to the power of 0. So therefore, log of 1 to the base 10 is equal to 0. 10 is 10 to the power of 1. So therefore, log of 10 to the base 10 is equal to 1. 100 is 10 to the power of 2. So therefore, log of 100 to the base 10 is equal to 2. 1000 is 10 to the power of 3. So therefore, log of 1000 to the base 10 is equal to 3. 10,000 is 10 to the power of 4. So therefore, log of 10,000 to the base 10 is equal to 4. 1 lakh is 10 to the power of 5. So therefore, log of 1 lakh to the base 10 is equal to 5. So thus, the logarithm is inverse function to exponentiation. Now, log of 1 to the base 10 is equal to 0, because 1 is equal to 10 to the power of 0. So we have written log of 1 to the base 10 is equal to 0, and log of 10 to the base 10 is equal to 1. 5 is the number between 1 and 10. So therefore, log of 5 to the base 10 is equal to 0.7, where 0.7 is the number between 0 and 1. Log of 10 to the base 10 is equal to 1, and log of 100 to the base 10 is equal to 2. If we apply log to any number between 10 and 100, its value will be between 1 and 2. So log of 50 to the base 10 is equal to 1.7. Log of 100 to the base 10 is equal to 2. Log of 1000 to the base 10 is equal to 3. So therefore, log of any number between 100 and 1000 will be between 2 and 3. Hence, log of 500 to the base 10 is equal to 2.7. Similarly, log of 1000 to the base 10 is 3. Log of 10,000 to the base 10 is 4. Log of 5000 to the base 10 is equal to 3.7. Log of 10,000 to the base 10 is equal to 4. Log of 1 lakh to the base 10 is equal to 5. So therefore, log of 50,000 to the base 10 is equal to 4.5. So this is how the logarithm to the base 10 is found for any number. Let's move further. So here we are using the log for whole numbers. It's not necessary that the logarithm should be applied only to the whole numbers. Now, how to find a logarithm of a number x? So it consists of two steps. Step 1 is to find a characteristic of the number, and step 2 is to find the mantissa. Once we find the characteristic and mantissa, log of any number x to the base 10 can be written as c dot m, where this dot is the decimal point. Now, what this is, you will understand in the coming slides. Now first let us try to understand what is characteristic of a number. If n is the number of digits before decimal point of the number, then the characteristic of that number is c is equal to n minus 1. So for example, for a number 4564, if I think of putting a decimal point, I should put it after 4. So therefore before decimal point there are 4 digits, and hence its characteristic is 4 minus 1, which is equal to 3. For 989, if I think of putting a decimal point, I should put it after 9. So therefore number of digits before decimal point is 3, characteristic is 3 minus 1, which is equal to 2. For 45, the decimal point should be after 5. So therefore there are 2 digits before decimal point. So therefore characteristic is 1. For number 7, there is only 1 digit before decimal point. So therefore the characteristic is 1 minus 1, which is equal to 0. Now you will understand much better if I go with this series. I have 1, 2, 3, 4, 1234, 123.4, 12.34, 1.234, 0.1234, 0.01234, and 0.001234. Now, if you see, the first 4 digits are same. The only thing is the decimal point have changed its position. Now let us try to understand the characteristic for these numbers. In first case, the decimal point is after 4, so therefore C is 4 minus 1, which is equal to 3. That's being a 4-digit number. For second, 123.4, the decimal point is after 3, so therefore before decimal point there are 3 digits, so therefore 3 minus 1 is 2. For 12.34, the characteristic is 2 minus 1, which is 1. For 1.234, the characteristic is 0. For 0.1234, the characteristic is bar 1. For 0.01234, the characteristic is written as bar 2. For 0.001234, the characteristic is written as bar 3. So write the sequence to understand how the characteristic changes as the decimal points keeps on shifting. For a 4-digit number, characteristic is 3. For 3-digit number, it is 2. For 2-digit number, it is 1. For 1-digit number, it is 0. And if the decimal points shifts before all the digits, it becomes bar 1. If it is 0.0 and then number, it is bar 2. If it is 0.00 and number, then it is bar 3. I hope you understood how to see the characteristic of a number. Let us move further to find the mantissa of a number. To find the mantissa, we need first 4 digits of a number, irrespective of the number of digits it has. So for example, for a number say 1, 2, 3, 4, 5, 6, 7, that is 12,34,567, the first 4 digits are 1, 2, 3, 4. So we need first 4 digits to find the mantissa. For 4,567.32, the first 4 digits are 4, 5, 6, 7. for 8.3. Even though we find that there are only two digits, we need 4 digits. So therefore, the digits are chosen as 8300 because the number 8.3 can be written as 8.300. And similarly, for 0.00912, the four digits should not be 0. So therefore, the digits are 9120. So to find the mantissa, we need the first four non-zero numbers. The number should not start with 0. So now let us generalize the first four digits as A, B, C, D. Now we make use of this kinds of table called logarithm tables to calculate the mantissa. So we have A, B, C, D as first four digits of a number. Among these, the first two digits are chosen from the first column. The third digit is chosen from the first row. And the fourth digit is chosen from the column of mean difference. Now, how do we use this? Now, say for a number 12,34,567, the first four digits are 1, 2, 3, 4. So, A is 1, B is 2, C is 3, D is 4. So, since A and B together make 12, the first row AB is chosen to be 12. The third digit, that is C, is equal to 3. So therefore we go with the number in the column of 3. So A, B and C together gives us a number 0899. So therefore mantissa is equal to 0899. But the work is not yet complete. We also have a fourth digit, which is 4. If the fourth digit is 0, then we need not move to the next step. The mantissa will be only 0899. But here we have fourth digit, that is D is equal to 4. So therefore we move in the line of 12 towards 4 mean difference. And the number that we get for 4 mean difference in the path of 12 is 14. We add it to 0899. So hence the mantissa becomes 0913. Let us try to work out the same for another number. For 24.722, the first four digits are 2472. A is 2, B is 4, C is 7 and D is 2. Now AB together is 24 and C is 7. So we go with the 24th row, 7th column to get the number, which is 3927. So therefore mantissa is 3927, and the thing is not at over. We have 2 as D. So therefore we move further in the row of 24 and the column of 2, and the value that we are going to get is 4. So when 4 is added to the number, the mantissa becomes 3931. So this is how the mantissa is calculated using the logarithmic table. So it needs great practice to find the characteristic and the mantissa, and it needs more practice to find mantissa than characteristic of a number. So once we find the characteristic and the mantissa, we can easily find the logarithm of a number. So we have found the characteristic, we have found the mantissa. Now we'll try to present the logarithm of a number. So what is log of 1234? Now first characteristic is 3 because it is a 4-digit number. And step 2, Mantissa from the table is 0913. So we know logarithm of a number is written as characteristic, decimal point and Mantissa. So therefore log of 1234 to the base 10 is equal to 3.0913. Now to make you understand, let us write few more. So logarithm of 123.45 is 2.0913. Logarithm of 12.345 to the base 10 is 1.0913. Logarithm of 1.2345 to the base 10 is equal to 0.0913. I have purposefully taken these numbers because if you find the Mantissa is same, it is 0913 for all the three numbers because first four digits of all the three numbers is same. Then what changes is the decimal point. For 123.45 the decimal point is after 3 digits. For 12.345 it is after 2 digits, and for 1.2345 the decimal point is after 1 digit. So therefore the only thing that changes is the characteristic. So characteristic for first number is 2, for second is 1, and for third one is 0, whereas Mantissa remains same. I hope you have understood the method to find the logarithm of a number to the base 10. Now there is a concept called logarithm to the base e. E is an important number in mathematics whose value is 2.71828818259045360287471357 and more. Now it's too big. We limit ourselves up to 3 digits after decimal point. This number E is called Euler's number after the mathematician Leonhard Euler. In physics, we use it in equations related to growth or decline of certain quantities. We have logarithmic table to see the log to the base 10, but in some cases we also need the logarithm to be calculated to the base e. So as I said, when we can write a number x in terms of power of 10, we can also write it in terms of power to the base e. So any number x can be written as e to the power n. Now how do we understand this? The logarithm of the same x to the base e is equal to n. Now we know, let us write 2.718 in terms of e, it becomes e to the power 1. Then in logarithm form, log of 2.718 to the base e is equal to log of e to the base e, hence it is equal to 1. 7.387 is equal to e to the power 2, so therefore log of 7.387 to the base e is equal to log of e square to the base e, hence it is 2. 20.079 is equal to e to the power 3. So therefore log of 20.079 to the base e is equal to log of e to the power 3 to the base e, hence it is equal to 3. 54.575 is equal to e to the power 4. Log of 54.575 to the base e is equal to log of e to the power 4 to the base e, which is equal to 4. Now log of 5 is a number between 2.718 and 7.387. So therefore its log to the base e should be between 1 and 2, hence it is 1.691. Similarly, log of 10 to the base e is equal to 2.303. Log of 40 to the base e is equal to 3.69, and so. So we have to calculate the log to the base e using log to the base 10. and we have a relation which says that log of any number x to the base e is equal to 2.303 into log of x to the base 10. Now log of 5 to the base e is 1.691. So therefore that can be calculated as 2.305 into log of 5 to the base 10. If you use the table, you will find it as 2.303 into 0.6989. We get it as 1.6095, approximately equal to 1.691. Similarly, log of 10 is found to be 2.303. Log of 40 to the base e is found to be 3.689 if we use the logarithms to the base 10. So this was logarithms to the base e. In texts, the logarithm to the base e is also called natural logarithm or Neperian logarithm. It is represented as log x to the base e or ln x, or ln x is also written as ln x. So this is called natural logarithm or Neperian logarithm. So try to see this video again and again so that you get familiar with the concept of logarithm. Thank you.